Okay, YouTube, in this video we're going to look at an application of function combinations. And so let's go ahead and take a look at what this says. It says from 2000 to 2010, the population in thousands of cities M and N can be modeled by these two models. And so for M, we have city M. Its population is given by this polynomial expression here. And N, its population, is given by this, where T is the number of years since 2000. So let's go ahead and write a little note here. We say T equals 0. This would mean the year 2000 because T is the number of years since 2000. And so for instance here T equals 1, well that of course would be the year 2001. So for that being said, we have our T value, which is the year, and that's our input value, that's our X value. When you give me the year, what this says is it's going to give us the population of each individual city. So what they want us to do here is find M minus N of T, which the very first thing we ought to write is this. It means the same thing as M of T, or the population of city M minus the population of city N here. So what we're going to do is we'll just go ahead and do what we know to do, which is just do our substitutions. So M of T is given by this 3.3 T to the third plus 12.1 T squared minus 0.65 T and then plus 15.8. So I'm going to have to squeeze that one up here. Sorry about that. Sorry. This one hopefully doesn't carry over here, but we'd say N of T is 2.5 T to the third. Let's see here, right there. And then we say, okay, so plus 7.8 T to the second plus 0.41 T plus 11.9. So in terms of finding this, and it would be a difference here, we would distribute the negative throughout. So in other words, I suppose we'd start with 3.3 T cubed, and if we were to distribute the negative, this 2.5 T cubed would become negative. So 3.3, if we just check this out here, we've got 3.3 minus 2.5. So we would get 0.8, so we have equals 0.8 of these T cubed things. Now we have positive 12.1 T squared, and this would become a negative 7.8 T squared. So 12.1 minus 7.8, so we have 12.1 minus 7.8, so 4.3, so we have plus 4.3 T squared. So now going on to our T's, we have negative 65 hundredths and positive 41 hundredths. So we'll go ahead and go negative 0.65. And we say plus 0.41 positive. And we would get negative 0.24, so negative 0.24 T. And we're almost there. We have 11.9 plus 15.8. As a matter of fact, I lied. And I need to fix this as well. I forgot to distribute the negative throughout all this. I was being lazy. The negative here would make this a negative 0.41. And this is a negative 0.65. So this actually becomes a negative 1.06 T, and then this 11.9 would become negative after distributing the negative here. So 15.8 minus 11.9. So we have 15.8 minus 11.9, and we would get 3.9. So plus 3.9, and this would be our new function M minus N of T. And so one thing we want to consider is this: explain what this function represents. And so what we said initially was this: take the population of city M. So pop of M. And what we're doing is we're subtracting off the population of N at any given time T. So M minus N of T, what this would represent, and we could type this out here, M minus N of T. Let's go ahead and type that out. We'd say the function M minus N, with capitals here, of T represents the population at any given time that results from subtracting the population of city N from city M. So if we were to take the population of N from M at any given time, that's what this function would represent. Cheers.